Okay, so before we start, I kind of want to touch back on lab one with the topology. Um, and I saw that you did really well overall as a group. So I wanted to borrow some of the student topology, and I hope you don't mind, to kind of show because as an some of you will be network engineers or security engineers, you kind of have to look at topology and see like how you can restructure the network or modify the design or add to the design so that way it's better. So from that perspective, I wanted to be able to share. So let me go to my downloads real quick because I grabbed this from some of the submissions. So this was submitted by one of the students. Sorry, let me get the thing to open completely so you can see. And it is a really good design to start, okay? So, when you look at this topology, what can you tell me about what can be improved? Because overall, right, we have a switch that connects the PC together. That was the request from the business, right? They had some workstation they want to connect. There's a router that's connecting out to the service provider, and there's an external firewall, which is a good thing. And then we have the wireless segment that's separate, which is a plus, right? We want to keep the wireless a little bit separate. And then there were some appliances or systems, such as the printers, the copier. There were some devices that were also missing from this because the telephone, right, the voice over IP phone needs to also be connected. So we can place the voice over IP over here because maybe this is a cubicle, right? So physically, if you want to represent your topology physically and logically just where the data is flowing, we want to be able to maybe add the phone because at each workstation, they likely will have to answer their phone. So we'll add some phones over here, right? So you have a switch that would mostly be for maintenance of maybe fax, copier, etc. Right? This one is also missing a server. That was the request from the business is to place a server. So where would you place your server? So I see a lot of diagram that was submitted, and the server was either sitting right here or right here, okay? Keep in mind that routers don't have physical regular router doesn't have a lot of ports. So you have to connect them to switches, right? So we can place the server right here, attaching to the switch, right? So this switch, assuming that it's going to be at least 24 ports. So you have 5 workstation, 5 phones, that's 10, right? A server, that's 11. And then you have another switch that's going to handle some additional IO devices. And then you have an AP. The problem with the AP is it's connecting directly to the router. Like I said, right? Most of the regular router would only have like 2 ports for LAN connection, and it would have a port out. So you should connect your AP to either this switch or this switch. Access point needs to be connected to a switch, okay? Kind of understand that a little bit?
Yeah.
All right. Now, from a security perspective, we can clean up a lot of things, right? Maybe server should be on its own switch. Now, once you're connecting all the switches back to the router, so normally we would have an uplink switch here on the backbone rack, and that connects to the router, okay? But from a simple business diagram, yes, you can connect the switches. So ideally, I would normally bridge the switches together only because you want to be able to have communication from this segment and this segment without going through the router itself, okay? So we are going to have a direct line that's going to connect the switches together, and they should have a port for that specifically. And if you use an Ethernet, that has to be a crossover cable. Some of the old switches would use coaxial. The newer switches, if they are fiber capable, right, on the backbone, usually a lot of the higher end switches, they have different media that is faster. So you would bridge the switches together, so direct connect them together. And I would clean up the layout a little bit. So this is great. Like it's easy to see, it's visible, everything's labeled, right? But think about like how you are sending print from this segment to this segment without having to go to the router. Understand? The router is a transit system. Everything that's coming externally in or leaving your network should be through the router. So if I'm accessing the internet from here, that gets sent through the switch and then to the router. Fine, right? But if I'm printing, that should be to the switch, another switch, and to the printer. Get it? Right? Okay. So that's my suggestion, is maybe connecting the switch together, right? Make them at the same level, put the workstation, put it here, attaching the access point to this switch, okay? And then internally, from a security standpoint, we need to have an intrusion detection system attaching to this switch. So once they get past the firewall, the alarm needs to go off if they're attacking us inside, okay? Okay with that? So you need to have NIDS here and NIDS there, and that should be a further discussion in another class. But overall, this is good. Okay, let's look at another one real quick. So let me see if I can zoom in. So this is another diagram that was submitted. Good, right? Also the same, switches are going through the router. So the switch should connect to the router in routing out data and routing in data. Also, you have the copier connecting to the switch. That's good because it's shared across both segments. You have a hub here, which is an unmanaged switch ultimately. And then you got some mobile devices here. The challenge with this one, you see it? There's no AP here, right? These are wireless devices, so they need to be connected wirelessly. So that means that we need to attach an access point here for these devices to communicate with the rest of the network. Is that okay? Okay. On this side, looks good, as I expected. It's actually great that this person put the printer right with the workstation, because ideally, physically, that's more a logical solution, because most people at their workstation, they need to print out invoices, receipts, etc. So you have PCs and printer accordingly, and the phones. Okay, so this part of the segment works really well. My suggestion for this is, again, connecting the switches together, like bridge them, and then attaching an access point here for the wireless devices to talk across. And then we will have to, seamlessly design IP addresses that works, and that's a later chapter. So the server, see how it's connecting at the router? It should not be there. Okay, right here. So we're gonna take the server, right? We're gonna attach it over here to the switch on the left. Now, can I put it on the right? You can. But again, like I mentioned before, the wireless segment of your network is the weakest part of your network. So we want to make sure that we can attach it. And then we would put some security appliance over here, and maybe security appliance, right, for the external network, like the one it routes out. Okay, you can have a border firewall that's attaching to a router. Take that server connecting to the switch over here, right? Add an AP, and this design is complete. Okay. Any question? So I want to give you a little bit of feedback, right, from a perspective of, I do this, right? So whenever I work with network engineer, security engineer, I'm gonna say, okay, this is the layout. We need to be able to protect this part and this part, put it on VLANs and so on. So you can redesign some part of the network or implement solutions that makes it work, and that's what you get paid for. Okay. Last one, I promise, and then we'll talk about the concept. Okay, and I hope Victor doesn't mind because I thought his design was really good, right? So let's zoom in a little bit. Okay. So physically and logically, this works well. Workstation with phone. Ideally, that usually is in a business environment. You also have printers with workstation and phone. So that works well, right? Attaching to this switch. You got switch number 2, have a wireless hub, AP here, that's good, right? The laptop connecting to that, the tablet. This one is missing a server as the business requests that the server is attached. So I would recommend adding the server to here. So this layout shows that everything funneled back to the router, which is right. Everybody so far is correct. But we would also need to bridge these switches together. Okay, so basically, physically, it's on a rack. The switch would have a cable connecting to another switch, and those two would have cable connecting to the router physically, right? And then we would run all the lines from these stations back to that switch, or you can add some baby switch, like the unmanaged switch too. Okay, so this one doesn't have too much to modify, except for bridging the switch and adding a server. Now, some of you like to put the server at like right after the router, right? And I put a comment that if you do that, that server role would become either a gateway or a proxy server. Normally we use proxy to regulate traffic like filter. We can also use a server, an actual physical computer, to be able to act as a gateway. Basically, it's going to narrow down. It functions as another router, kind of. So the router is going to pass to, and it's going to determine, right, where it's going to go. Like, how you exit, you either turn left or turn right. That gateway is going to determine, is this traffic going to be on the left side, or is it going to be on the right side before it forwarded to the switch. So you can use it as like a forwarder server. Yes. So if you put the server where my cursor is, then that server role should be a gateway or a proxy. Okay, like a proxy server is basically access a filtering system similar to a firewall. We can use it to regulate traffic, like a traffic cop. You know how there's a traffic cop at the exit? That traffic cop's going to be like, oh, you can turn left or you can turn right, depending on where you go, right? So if you put a server there, that server, its job, the functionality of the server is going to regulate the traffic on where that's going to branch out. Now, if on a regular authentication server or a file server, it needs to be on the inside, right? It needs to be connecting to this switch or this switch. Now, if we're connecting to this switch, we make sure we want to protect it from the rest of the wireless network, right? Of course. So it's like every person has a role in the company, and the system is like that. You have servers that are for authentication, and you have servers that are for files, and we talked about that last week. We have server for print. So if you add a server to this area, I saw some diagram that did really well. They had a switch with all the copier and the printer and a server sitting right there. So when I looked at that diagram, automatically my mind goes to print server. So that server can be functioned as a print server, right? So depending on the role of your server, you can kind of think about like where you place it logically and physically. Okay? Because not all servers are the same, they're kind of different. So read my comments, and I still have about 20 more to go through. And I'd like to put some detailed comments about your part B, because your part It is great. Like you draw your home network and it's beautiful. Right? And that's what I want to see. But part B, my feedback for you, so that way after this class you will improve. Right? Any question? Okay. I didn't do this for Friday, so this week I'm gonna talk to my Friday group about that because okay, so now let's go into the notes for chapter 2. And then we only have about 20 questions or so, so it's quick. And our assignments. I know some of you started working on this and submitted it already. We briefly talked a little bit about the terminology last week. Every time that you think about protocols, those are rules that are used to format how your information is being serviced, right, by the system. So that way, regardless of the brand of the technology that you're using, like Apple or et cetera, right? So some specific brand like Windows would have its own set of protocols where there's some protocols that are shared across all types of systems. So in the first question, it asks you protocols. What is a protocol? And you can refer to page 1. So let's go through and answer those. Question 1, what are network protocols and how are network protocols used to establish system communication? We kind of see that, right, from the note. So it is a set of rules that was standardized for your system so that way it can format and process data. So when we look at HTTP, right, hypertext transfer protocol, the P stands for the protocol, that is used to format your web content, right? HTTPS, it has also service the web, but it provides you security with encryption. So it also utilize, right, additional protocol in order to do that. Okay. So you always see protocol is tied to a type of service, right? Some kind of service that the system provides. And so when we use the service, the system has to receive and send information. That means that if I'm using web, it needs to receive web content requests and send that to the requester or the client, right? So that means that I have to have some kind of ports, and ports is a door or a window to that system, right? So you would always see a port that would tie to protocol and service. So it says the use of protocols enables them to communicate with each other regardless of the software or the hardware that you use. So if you use an IBM system, or if you use an Apple system, Windows system, a Linux system, right? A lot of the protocols are standardized for, right, cross-platform and cross-software. So software as an operating system, right, or application. So what we would see is that protocols allows us to do that. Now, 2, it asks about net viewing, and you can read that section where it talks about net BIOS with extension, right? So net viewing is an extremely efficient protocol. It simply allows us to be able to route packets, and this is a legacy technology, an older technology. Historically, this was used for like Windows, early Windows version, post-DOS, where we didn't really have IP address back then. TCP/IP networks was not in existence. So they have to come up with a way that the system can route, right, based on host names. And NetBIOS is still being integrated in your current version of Windows when you go through and install it. And when we go through and set up DNS, you're going to see that, right? So the advantage of using net viewing is that it is easy to configure for the system that you want to network. And it doesn't require a lot of configurations for the communication. Now, your system still has an identification as host names. So when you install, let's say Windows 11 on a computer, right, you would have a default system name, or you can change your system name. So back in the day, we can use up to 255 characters to be able to name our system. And in order to get the data to that system or from that system, we would identify it only by name. We still do that in the back, right? But now we're able to integrate additional protocols so that way we can use addressing. And that allows us to streamline the communication globally. And you can find this on page 1 of your Unit 2 notes, right? You can summarize it, you can grab it from the notes. So with that, we need to talk about routable and non-routable protocol, right? So some protocols we can use externally and internally, meaning that it's able to get your data, your formats, and provide you service from your system to the router and external network, right? Leaving your network. Some protocols are only used internally. They are non-routable. It will not be passed through to the router. Okay? So, and it touches on that on the first page of your notes. Now, with NetBIOS, right? NetBIOS is an extension of that with the UI. With NetBIOS, what you see is when you configure it, there are 2 modes that you work with. One is a session mode, right? And this relies on connection oriented. So that means that the connection has to be established in order for that communication to happen. And you see this in the current protocol that we use, which is TCP, Transmission Control Protocol. So the session mode requires that the connection is established, right? And you're able to monitor the session to see if there's any kind of error. So in the case that system A sends to system B, and if there's a disruption or any kind of error in the transmission, it will retransmit. And we want this reliability in our system. Just imagine, right? If you trying to access some kind of web service and there's no guarantee, right? This is what happens in the 80s. There's no guarantee that you can or you cannot get that content. Then we won't have the type of app and the type of resource that we have today, right? The instant, response in our system and the accuracy in the data that you receive. So technology-wise, from the legacy protocol, that's what we see. So session mode requires that you have to be connected, right? And in the case if your data is missing or corrupted, it would notify you. Then it would retransmit. Now the datagram mode, this is what you see with UDP. The datagram mode is connectionless. It doesn't care if the connection is established or not, right? And if there's some kind of error, oh well, right? So less reliability in this mode, but it's able to give you faster response. And this is what you see with UDP. So from this technology spawn, right, your TCP and your UDP, that's what you see today, right? And we want to have the adaptability from our historical technology so that way we will continue that and improve it. And that's what technology is, right? We don't reinvent the wagon. We just take the wagon and improve it into a car, a Tesla, and eventually a flying vehicle, right? So what we see is we had this technology and it's still being used in the back somewhere on your OS. But at the same time, we have now newer protocols that's adaptable, but same concept. Okay. Okay, so with that said, we're going to talk a little bit about TCP. So internet is now, everybody is built on transmission control protocol, your TCP, and you must know this for your quiz and your exam and certification, TCP. So transmission control protocol is a way that we make sure that there is one connection, right? So if I'm transmitting data, right, I'm system A and I'm transmitting data to him, system B, the first thing is has to happen is it's gonna say, hey, are you ready to connect? I'm gonna tell him, are you ready to connect? And he said, I'm ready. And so, okay, now I'm transmitting, right? So there are communication back and forth between system A and system B to make sure that there's connection, right? And who's sending and who's receiving, or when it's ready to send and receive. Once that happens, then the communication occurs. And this is what you see with the time that you use your browser to load your website, right? To the time that you get the web content. Okay. Now, IP is purely for addressing, right? It's purely being used to be able to identify which system is which. Who's the source and what's the destination, right? What, like, you know, if you're trying to send a package, well, you've got to put an address label on your package, and that's the same thing. We have to identify who's sending and who's receiving. Now, the thing with TCP and all your data in RAW doesn't come in one package, right? So when I'm sending data, it doesn't mean that it's going to send it's one, let's say I'm downloading a movie that is 2 megabytes, right? I'm not getting the packets with 2 megabytes of payload. It's going to chunk it up into portions, right? Because, and we're going to talk about flow control in a little bit. Because if we are sending everything as a bulk like that, it's going to take a long time for the system to send that through, right? So it's better if we just kind of chunked it up. And with TCP, it's like I'm sending a bicycle to my friend, okay? And TCP, it's going to say, hey, are you ready to receive a bicycle? And my friend said, okay, I'm ready, right? And it's going to send. And the bicycle is broken into pieces, a handlebar, a pedal, a wheel, right? The frame. And when it gets to the destination, it's going to put everything back together. We're going to talk about the layer that's going to handle that. Present the bicycle to my friend, and that's what you get with TCP, okay? Everything has to be back intact, and that's what you get. Now, UDP, when we talked about user datagram protocol, it's gonna still send, right? It doesn't, if there's no, you're not required to confirm that communication is the status. It's gonna say, okay, it's sending. And the bicycle, again, is broken into pieces. So when you're loading your video, some parts of your video, later part of your video is already arriving before the beginning part. For example, I'm watching a movie, the beginning credits might not arrive yet, but some frame of the video in the later part has already arrived, and UDP does that. It's going to give you fast, right, output, but it's going to give you things that are not necessarily in the entirety or the order, okay? Now, your packets have some way to track, like which order, and it's still going to present you the video as what you see, but we're going to talk about sequencing in a little bit. Okay. So the design for TCP include rerouting packets, right? And whenever that you see IP is for addressing, and it's purely used for routing one network to the next network, right? Router is a transit system. It gets you from one city to the next, right? So public IP for our global networks, and then internally, if you route within, right, that we would use private IP within our network, and we'll talk about different subnet for that. Okay. So regardless of the OS that you're using, right, the software that you're using, you still be able to use this particular suite. Okay, I think we touched on the routable and non-routable protocol. So routable protocol whose packets may leave the network and pass to the router, and it's delivered to the destination network. So this is how you're able to get your websites, right? Access web application, download files, right? So those protocols can be handled by the router. Now, on the other hand, the non-routable protocol do not have this capability. So it won't be able to send, right, or pass that to the router, or from going from network A to network B. So the router know that that is a system that is allowing us to go from one network to the next network. Hence your wireless router at home, right? You're using your home network, and whenever you're trying to access the internet, you're going into someone else's network, right? Your service provider or other company's network. And so simply because the protocol does not accommodate, right, the addressing, which is what you see with IP for the packet. So it won't allow that to be included in the packet header, so it won't be able to pass. So we'll talk about frame only for switch and switch handle frame. So packets is, usually that is handled by the router. That's layer 3 though. Any question? And you can find this again on the notes itself, right? I'm going to go ahead and move 5 down. So, and I hope you got 4 so we can see the next question. And move 6 up. Okay, so let's break down some of your common protocols, and I might not go all over all of them, right? Like I mentioned before, in the IT and cybersecurity industry, you must know your protocol and you must know your port number, because when you're using tools like security tool, when it scans, it's going to tell you port 20, and you have to know what that is, right? Port 20 is vulnerable, and you have to go and fix it, right? So we want to know what it does, right? Which port. And so we're going to go through some of these real quick. And you see this in 27 and another class as well. But you repeatedly, if you start to kind of go through these, you're going to be more familiar with them, and it's going to get easier. So 6A, when you're transferring file between two systems, two computers across an IP network, right, using no encryption, right? So everything can be seen in plain text. Then you're using what's called file transfer protocol, FTP. And in existence, there are still FTP servers today, right? Mozilla has one, but now what they're requiring is you have to authenticate. And this was originated for people to kind of share files back in the day, right? Companies can implement FTP to be able to, have the employees go into the server and be able to download. FTP was notorious for having an anonymous account, meaning that you can't just use an anonymous login and be able to download and upload files. But because security has changed and the requirement has changed, we want to have accountability in who's downloading and who's uploading. They could upload malware for all that matters, right? So we want now, most of the file server is using secure file transfer protocol, and they have authentication ties to it. So FTP uses port 20 and 21. So whenever you scan, right, I do a lab in my ethical hacking class where they grab a banner from the server, and if it shows port 20 and 21, that's FTP, and you can do something with that from an attacker standpoint. So this is vulnerable. Okay. Now, if you're using email server, right, like your student email server, Microsoft Exchange, most companies would use that, or another form of Exchange server. So server email delivery in the network, that's known as Simple Mail Transfer Protocol, your SMTP. Now, this is important to also know for computer forensic, right? Because we have to sometimes find where that email comes from, which server handles our email. So whenever that you deal with email delivery server, right, like the post office delivery, your postal mail, right? So there's a system that handles how your mail get to your inbox, right? And how your mail gets sent from your account. Okay, so it uses port 25 SMTP. See, client system connects, there should be grammatically, we should fix this, connects to webmail servers to access emails. And this is what you see with POP version 3, Post Office Protocol version 3, TCP port 110. And you notice that these are TCP, so there's reliability with the protocol. Like I said, right, about the bicycle, it has to make sure that it's connected before it sends, and when it gets to all the parts together, it's gonna present it. So under the TCP, you would have other protocols that's under that suite, right? So port 110 for web mail servers. So if you look at Yahoo, Outlook, Live, Gmail, right, it uses the web component, but Google hosts their own also server to be able to exchange, right, set up Outlook, time to your Gmail account, etc. Then what you see that traditionally that's POP version 3. And then this is how you're able to get your downloads, like your image and your search, okay, is IMAP. So IMAP is Internet Message Access Protocol. This allows you to have, the pretty content in your email, like a banner for advertisement, a JPEG attached to your email, so you can have downloads, or a Word document. And then you're able to search with using, like a keyword, or an email address in your inbox is IMAP. Then that uses port 143. And again, it's also under TCP. Then you have Windows system connecting to another computer to run programs. And you can do this for cloud purposes, or you can do it like using TeamViewer, to be able to connect one system to the remote desktop, so that way you can troubleshoot. You see a lot of that with tech support. So if I need to go and install anti-malware on my client computer, right, as I am a tech support person, I can use the software to do that, or I can create a session with RDP. This is only for Microsoft Windows. And I've done this with Azure and also AWS, where I would turn on my virtual machine on the cloud, which is someone else's server racks, right? And I can remote into it. You see RDP used a lot for administration purposes, for configuration purposes, right? But you have to turn it off when you're done, because if your session is open and available, someone can get on your session, right? So we want to be mindful of like how that service is used, and it uses port 3389. Okay, so if you're using HTTPS, like you're logging into your school Canvas account. Or let's say that I want to go to my credit card and I want to be able to pay my bill, right? Pay my balance. I would type in, for example, citibank.com, and I would be, I would see, my login screen, and I would type in my username and password. At this point, once you're authenticated, it creates a session, right? A secure session, an encrypted session. And ideally, with that security, they're not able to see what you're doing on your account, right? Like if I'm looking at my statement, if I'm clicking pay bill, etc. And with that, when you're using HTTPS, it's including your transport layer security, your TLS, which allows you to have a secure session after you authenticate, right? Now, some website would also have SSL, usually either or, right? Secure socket layer, but when you're using SSL, it has to be the newest version. Otherwise, you're gonna have risk. And these uses port 995 or 465. 995 for TLS and 465 for SSL. Now, if you have taken CIS27 or other security classes, I see some of you have done that with me, right? You know that we can strip SSL, right, using a tool. So an attacker can do that, right? They can degrade your security level in that session, and so they can do man in the middle, right, eavesdropping, a lot of other forms of attack. So having security component only buys you time, right, in the service, but you can't rely on it 100%. So in the networks, we know that these traditionally been around for a long time and integrated, and we improve them as well, right? So you have to know your protocols and their flaws. Okay. And then G, construct and deconstruct multimedia communication section, such as voice, video, calls, right? So your voice, video conferencing, streaming, multimedia distribution, instant messaging, online games over the internet, etc. And this use SIP, session initiation protocol. You see this a lot with like your video conferencing software or tool. And it uses both because it's streaming, you tend to see UDP, user datagram protocol. Remember what I said? Fast but unreliable, right? This guy is reliable but slower. And it uses port 5060 or TCP 5061. Now, these are the common ports. These are agreed numbers, right, by the industry, by everybody, saying that this is for this type of protocol. Can you configure that protocol using an uncommon port? Because you have thousands of ports to use. Sure, right? Just gonna make sure that you set that up in your system so that way it knows that that's the port that it's using. That's the window or door for that service. Okay. Simple Network Management Protocol uses UDP 161. This allows you to do inventory of your devices. For example, I'm the network admin, and my job today is to make sure, right, that all my systems are connected and updated. Updates different than upgrade. Updates is, like updating your software, making sure that we're patching all the issues on our software. So the first thing I need to do is to make sure that all the systems are turned on. And I would use Simple Network Management Protocol. This can be integrated into a switch technology, right, or a server. So I would make sure that it's going to pull the devices. It's going to check and make sure all my thousands of systems are connecting. If you deal with 25 systems, it's easy, right? You can manually go and physically check it. But when you're dealing with global companies that are across the world, when you're doing management like that, it's easier to do SNMP, Simple Network Management Protocol. It's going to gather all the LAN information from your system, right? And then you can either write a script to be able to streamline that. I did that for my CIS30B and C class. So you can say, you know, you can write a Python script and you can have it, right, submit it across the network for thousands of systems, so that way you don't manually go through, and it saves you time, and then you go have coffee, right? So, back in the day, we had to do this one by one. Who wants to do that anymore? We have technology to be able to streamline that. So when you see SNMP, that's simply for network management purposes. And maintenance, 161 is UDP. Okay, synchronize time across the network. And we see this, right? Daylight saving, you wake up Sunday morning and you're like, oh, fall, I save an hour, right? Fall back. So, but you look at your phone and you're like, oh, I don't have to adjust time, right? Back in the day, we didn't have that. Now, as long as you're connected to the network, guess what happened? Your system synchronized and it's beautiful, right? But synchronization really worked in the back end for the purpose of batch job and databases, right? Like when you go to your ATM machine, you pull some money, right? And then you go to another ATM machine an hour later because you spent your money, you're gonna pull some more money. And it shows, right, that even though they're different locations, it's supposed to update the information, right? So the ATM machines submit that transaction and updates the database, and they don't just use one database at the bank, they have many databases, right? And it would synchronize the data across the databases. And at the end of the day, you notice that it shows pending, right? They do a batch job for 24 hours. So at the end of the day, at 1 or 2 a.m., some admin or some person would take that information and update it so it would deduct the money from your account accordingly, right? Or if you deposit, add some money to your account. It doesn't update that right away because it is a batch job for databases. But systems don't synchronize if you have a time gap. Okay. And this works also for Windows Server. Windows have a 60 minutes leeway. So let's say that I hire an employee in New York. Okay. And that's my corporate office. I enter that account information. I added that user account, create a password, right? And that account's linked to their email and all of that. I onboard this person. And now I send this person to Southern California to be a manager, right? The next day, this person got to California, right? It pushes the account information from my corporate office to the server, right? In California within the hour, right? So it allows the update for that account. So even if that person logs in a few hours later, they're able to access their login, right? Their account, their email, all of that. So you would do that through synchronization, and you must have the appropriate time. So it uses network time protocol. Now these protocol has problems, right? So you see that with denial of service attack and other things, and that's for another class. But and then server that assigns IP address to the computer. So when you start your computer at your desk, right, your computer receives an IP address from the server, which is DHCP. Okay. So if you do IP config /all, sometime you would see your DHCP information. This is a job of your wireless router at home. Okay, so if you go in, it actually gives you that 192.168.x.x IP, right? So your wireless router gives out these IP addresses. So it doesn't have to be a server system, right? It could be appliances that does that as well. Okay, any question? So TCP information, non-routable, you can find that on page 2. And then all the protocols, most of the protocols we've gone through, right? STP. So SFTP uses also port 22. Why I say also is because if you're familiar with SSH, which is secure shell, This is used to direct connect to the system, and that would be using port 22. So if you're using SSH, for example, I have a Raspberry Pi and I have a laptop and I want to connect a laptop to my Raspberry Pi so I can, you know, create some cool program with my Pi, I would use SSH. And SSH also uses port 22. So we also use SSH to connect our system to like a switch or a router for configuration. So you should use SSH instead of Telnet because it is using encryption. So it's better. Okay. And Telnet is not a secure service. Okay, the only few that I didn't go over was for RTP, and we'll come back to this when we talk about switch technology for voice. VoIP. If you want to get into network administration, I would encourage you to get certification that is related to voice over IP. Everybody uses it. And if you're looking for like tech level 3 for network administrator, they usually require you have knowledge or skills in voice over IP. But RTP uses real-time transport protocol. This is particularly formatting for voice over IP audio and video, and this is what you see on how it transmits. Similar to kind of SIP, but SIP is more on like video conferencing and streaming media. You can accommodate it for streaming and video conferencing, but if you grew up like how I grew up, which is many decades ago, right? They used to have, you know, devices do push talk. You hold down, kind of like, you know, the walkie-talkie, kind of like that, right? Yeah. And eventually Sprint and Next, how they went out of business, but that was a technology that was used, right? Capitalizing on, you know, the push radio, you know, the walkie-talkie that you have. So it also can be used for that purpose. And then, you know, we can talk about multicasting and all of that later. And then your MGCP, which is your gateway control protocol. This is used for session handling, for conferencing, for media gateway. So if you have media servers or video streaming, you likely would see this type of protocol being used. Okay. SSH is here. And then your HTTP. And this one, I covered this on Friday, so I'll mention it again. So we'll come back to this when we do Active Directory. So lightweight directory access protocol. In Windows environment, we use this for Active Directory, which is a role that your server would take on to maintain a database of user accounts and systems that are connected to the network. Lightweight directory access protocol can also be used in other products outside of Microsoft Windows, right? But Active Directory, often you would see that using LDAP. And this is a way that you can have a directory of who's who, right, on your network. Like when you log into your RCCD account, right, your account exists in this directory at RCCD network, at the domain level. Okay, so we'll set up something like that. You will create user accounts and all of those things. I used to be an AD admin, so AD is my jam and I love it, right? But I eventually straight moved away from just Windows certifications and all of that. You know, I got my foot in the door because I had Microsoft expert certifications, and that landed me in, you know, the prior positions as administrator. But as you know, 80% of the business still use Microsoft product servers, unless it's web servers, but what you see is, you know, it's still highly demanded as Microsoft certification. Question? Okay, so look through these. And then one more I want to mention before we move to the next topic, right? So your SMB server message block, I think I talk about this in my CIS 27. It's mostly for sharing access to printers and files. And SMB comes up on Microsoft vulnerability a lot because there's issues with the software that's, and the service that's integrated into the OS and application for Windows. So you tend to see a lot of vulnerability with that protocol. And also domain name service, this is, we talked about the DNS is tied to the web server. This is what you see as domains for your web, right? But in security, from a perspective of security, we'll set up a DNS along with Active Directory later on in the class. You see DNS records being poisoned. This is how they can route you to specific servers, especially if they're doing phishing or something like that, right? So it's really a way for a human to go around and say, hey, visit my website, right? YouTube.com, instead of saying, visit my website, right? 12.4.9.11, right? We don't want to go around saying IP addresses. So domain name service allow us to tie FQDN, your fully qualified domain name, to a public IP address that's either leased or given to you. Okay. I'm sorry? Yeah, it basically has a record, that association, right? So it goes to that record to say that this is the domain name and this is the IP address, the correlation between those two. Now, when they're doing DNS poison, what happens is they take that record and they modify, they insert their IP address in there. This is how they route you to their own server, right? It's a simple process, right? So if you don't protect your DNS record, you're in trouble. Okay, so you use DNS security, and that's another topic. We'll come back to this when we talk about DNS and further. Okay, so let's talk about OSI layers, and you must know OSI for Network Plus, right? I guarantee that you're gonna get a few questions on OSI. So this was a model that was created so that way we can have many different vendors for your network devices to be able to allow you to have the services and the communication you have. So for example, right? I can buy an HP laptop, right? And it should function and connect to the wireless network as a Lenovo laptop or a Dell laptop or even a MacBook, right? So it is a model that the industry follows so that way we can have everybody standardized in communication using protocols and standards. Okay. All right, let's talk about these. So the first layer of the OSI is known as a physical layer. And this is when signals, right, bits are sent and received at the wire. So when you're making your cable today, you got to think about physical layer, your layer 1, because when you cut up, right, you strip your cable, you would see these copper wire, you untwist them, you put them into a connector, right? Your signal is being sent through your copper wire, and if you're using wireless, then it's being sent through the air, right? Now, the time that you turn on your computer and you're connecting to the wireless network or the wired network, it's already going to the layer 1, right? At your network adapter and your cable or at your wireless adapter, right? That's layer 1. Layer 2. Okay, I skipped for number 8 is layer 3, and we'll talk about that. Your layer 2 is your data link, the switch function here. Okay, this is where your data is framed. So it puts it into a frame and it would create a header for your data. Okay, now it uses a physical address that is given to your network adapter, wireless or wired, right? And the MAC address, your media access controller address, is programmed or ingrained onto your adapter. Okay. So this is how the switch can distinguish between this computer and that computer there, because there's different addresses. Just like how you have many houses on the street, right? Each house has its physical address. Like house number 1 is address 11, right? But house number 10 is address 25, right? So the switch can determine, right, which system on that segment that it needs to pass the data to based on the data link layer, which allows us to have the logical link control, which is making sure that there's accuracy in data, and also to determine which system by the physical addressing. Okay. So layer 2 switch function here. And when it's switched, it puts your system information on a table, right, to keep record of it. So if your system consistently receives more data, it just goes to the table as a reference so that way it can quickly find it. Now, if the system doesn't receive additional data and eventually that records become stale, then it flushes it out. Layer 3 is networking. This is where it routes. Okay. So this is where your IP comes in. This is where packets is created, and the router function here. This is where we can send data from one network to another network. So the next answer, right? Device IP addressing and is accomplished in which OSI layer, and that is the network layer. So when you're dealing with IP addressing, that's layer 3. Routing happens in layer 3 as well. Okay, before we answer 9 and 10, let's look at the other layers. So after it uses the address, it creates the packets, right? The packets would have the packet header, kind of like the label on the package, where it would know which system is sending and to which system is receiving. And that's different than the frame, because now the packets is used by the router, whereas the data frame at the layer 2 is used by the switch. So you're looking at the local area network. Now we're leaving that network going into another network, right? So it needs to have layer 3. But in order to get the data from one network A to network B, it needs to go to the transport. This allows you to have, right, the logical connection for the service from system A to system B, from network A to network B, right? What you have is you have the transport in the internetwork. So think of transport as like all the logistic truck that handle your package from California to New York, right? Like train, plane, the trucks, etc. So transport does that. It gets you from start to where it's supposed to arrive. Now, when you deal with session, this is where your system have communication, right? So once it gets you to where you're supposed to be, your system has to talk, right? So the session occurs here. Simplex is one way, half duplex is where it can send or receive. So send only, send or receive, and send and receive for full duplex. Okay. And so when we look at this, we can say communication can be, if I send only, your router does that, right? But it's actually a full duplex. A system can broadcast everything. Like when you listen to the radio, when they say broadcast, you can only hear them. They don't hear you, right? That's one way. That's the simplex. But when it's can either or, I can send or receive, that's a half duplex. But a system can send and receive. That's like your router, your computer is a full duplex, where it sometimes receives and sometimes sends, or both at the same time, full duplex. Okay. All right. Now, so once we have a session, right? So I received a package, right? I now would then get all my data. Okay. So when you load your website, the presentation, its job is to take the HTML code, right, and convert it for you. So that's what you see, like the video that you see, the image that you see. And then how do you see it? Through your browser application. That's an application layer. So when we're using the internet on a daily basis, we go through these 7 layers, period. Right? From connection to established communication to getting our content from the web. So presentation is the answer for 9, where your code for your data is translated, and application is how we would interface with the program or the system. Like your browser is a form of application, right? Okay, so all the layers combined, you have physical data link network transport session, presentation, and application. And I've been teaching for 20 plus years, and this is something that one of my classmates actually told me. She's very successful now. She came up with the saying, people don't need to see purple alligator, and I always remember that because PDNTSPA. Some book have a saying about pizza, whatever, right? So whatever that's easy for you, try to remember the acronyms or the letter trying to be 7 layers, because you are gonna be asked to answer these questions for your certification. So layer 1 start with physical, right? And then layer 7 application. Okay, so we talked about how a system needs to be connection oriented, right? To have so making sure that these two agree for communication physically, right? Have the connection established. And why do they do that? Really, it is a way to really set up rules for connections and acceptance and data synchronization prior to data transfer. So when we are using a network monitoring tool like Wireshark to be able to monitor our system communication, you would see like TCP traffic, and you would see that, you know, when we have a system like going to access a web page using HTTP or HTTPS, the client system negotiate or communicate with the host and say, hey, I'm requiring your service, let's connect, right? And the host would say, okay, so when you see that, there is synchronization and acknowledgement. So when you're scanning and monitoring your network, sometimes you would see SYN, right? SYN, SYN stands for synchronization. Basically, the two systems agree to synchronize. Let's communicate. And the system B is going to say, okay, I'm ready to synchronize. It sends the acknowledgement tag. Okay. Once that happens, it's going to pass the data. When it's finished, right? So you're going to see SYN. When it finished, it's going to do a fin for finish or final. Okay. Now, can they do a SYN attack? Sure can. Right? So they can capitalize on this negotiation and communication and agreement between the two systems because that's the technology we use. But simply, it's just a way that we would establish the connection rule and acceptance between these two, so that way we can synchronize and transfer. So ultimately, everything that you use does this, right? When we are downloading files, it just synchronize and transfer data from that system, right? When we're uploading files, right, it's synchronizing and transfer data from our system. Okay. Any questions? Almost there. We just have a few more to go. So but I want you to spend the time, if you have time later on this week, to look through the OSI, right? I give you some images. It talks about like the functionality of each of the layer, which device handles each of the layer, and then the SYN act happens here, okay? This is important because when you are monitoring the network, which is part of a lot of the regular activity, or when you pull logs from the network or get a capture in security, we're going to see a lot of this. So when we do a Wireshark lab or the network monitoring lab, you're going to see this. So that way you're familiar with this. So it comes back to here, right? The SYN act. Okay. Connection oriented and then connection less, but we're going to talk about flow control. So, like I mentioned before, flow control is a way that we can regulate how much data can be passed through the network. So just imagine if we have bulk data, which is what we do now. Our data is huge, right? Hence the term big data. We access a lot of data, we transfer a lot of data across the systems globally. But when you're looking at like inside the network, if we don't have flow control, we're gonna have congestion. Okay, we're gonna have delay. We're gonna have latency. That's the term, latency. We might have loss of data or missing data, right? So ultimately, we have to find a way to really govern or regulate the amount of data that can be sent between the systems. So that way, we don't have what's called buffer overflow. So if you think about this, all computing systems have RAM, regardless of the system. A switch has RAM. Your computer that you're sitting at, which is a client system, has RAM, right? And the server has RAM, the router has RAM, everybody, all the systems have RAM. RAM is a way that we can store, right, the processes and the activities for that system. So remember what I talked about the switch table earlier? Where does that store? In RAM, random access memory, right? Now, when that amount of memory is filled up, right? So RAM is in charge of buffering, okay? When that amount of memory fills up, then you have buffer overflow. So when you're looking at denial of service attack, ultimately is a form of buffer overflow, because when you have a bunch of requests that is submitted to that system, guess what happens? It dumps it into the RAM. And when it exceeds that limit, what happens? It cannot store anymore. It gets confused and it halts. Act, or it won't respond anything. It's like, you know how when you go to a person and you keep asking them many questions, eventually they get so occupied with thinking about the question, they can't respond in the system. That's what happens. Is if you have thousands of requests or hundreds and thousands of requests, it's going to fill this up, and it wouldn't know where to go and retrieve which request is first. And eventually it slows down and it stops. So how do we combat this? Give it more buffer, right? But easier said than done, right? Because RAM is expensive sometimes. And when you're looking at, and I tested this with my ethical hacking class. So if I give it 8 gig of RAM, right, and we launched the attack for denial of service, it doesn't take it down the web server. But if you give it 2 or 4 gig of RAM, right, like it barely hangs on with just booting, right, boom, it takes it down just like that. So yeah, it's all about allocation of resources ultimately. Okay? So flow control allows us to regulate how much data can go through. Like, imagine if there's no traffic on the freeway, right? Because traffic is regulated, wouldn't be great, right? You would be happier, everybody would get to places on time, right? So network performance is really about how you manage your resources accordingly. That's effective. Okay. Any question? All right, the switch operates, I mentioned this repeatedly, make sure you know that it's layer 2 switch, right? When you look at the switch, most switches operates here. Some switch can be used at the higher level, like layer 4. Those are used for voice over IP, right? It would need to have session, it would need to have, and it would be able to route. So most switches would be at data link layer 2. What happens at the physical layer? Well, your network adapter, your network interface card, your NIC function there because it receives bit by bit, right? Data in 0 and 1s. Your cable is the media that sends 0 and 1s, the bits. You would see sometimes like transceivers or repeaters. So the repeaters just take that signal and repeats it. When do I use the repeater? When you drive by the large palm tree that's fake by your T-Mobile, Verizon, or whatever service that you use, simply that is a way for them to repeat the signal across. You might have a repeater in a network like this for wireless, right? For access point. And then your hubs, which is like a system that and also contains repeat mechanism, but the hub doesn't care about the error. It doesn't retransmit too well in case of error. It just transmit. Question? Okay, so your router operates in layer 3. And in layer 3, packets are created and IP addresses for routing purposes. So network layer is layer 3. Make sure we know the layers. Make sure we know the device correlated to the layers. Make sure we know what's happening at that layer. That's important. Okay, so where can I find this information on my notes, right? After the flow control, you can go down and it talks about connectionless communication, where it doesn't notify the source that it needs, to receive. So it could just send whenever. And then the devices of the OSI layers, we touched on this just now, so you can go here. And I want to mention a little bit about encapsulation. So when your system sends data, it encapsulates it. This happens when you're making a phone call, right? Your data, as you know, transmit across the wireless network that you use, your mobile network, in 0 and 1s, and it sends as packets. So when you're looking at that payload, your voice originally is an analog, which is a wait format, gets converted into 0 and 1s, which is binary, right? So when that happens, it converts that before it sends it, but it has to be done quickly because otherwise the conversation that you have can be very long, right? Like I would say something and maybe seconds or minutes later, the person would rehear it, right? Communication has changed because we have now very high throughput. So your data is converted for transmission. And at this level, what you see is we are inverting the OSI, right? So let's say that you're using FaceTime app on your iPhone, and that is happening from here down, okay? But ultimately, it needs to send that, the binary, the converted data to your mobile network, so that way people that you call can hear you. So it's going to go from application, presentation, session, transport, and all of that through the mobile network and get to the device. And when they hear you on the other end, the receiver, the person that you call, it's happening again on their device. Same thing, right? But in the background, this is what happening is you have your data that is encapsulated, right? It's going to add in your TCP header so that way your data is reliable. It gets from point A to point B, right? Now it routes through the mobile network, right? And then eventually it gets to their network, right? And then decapsulates, converted back. So from the binary, now it then converts it back into analog format so you can hear the people you talk to. And this needs to be done fast. Otherwise, we would not be able to communicate well. We will go back to the 20s and 30s where, right, the conversation would need to be like very long when you're trying to communicate with someone across the nation. Okay, and here it talks about frame. So a frame is different than the packet, where the frame is used at the switch level and the packet is used at the routing level. Okay. So how does data get transmitted across the network? One, it needs to be wrapped into the protocol. And so when you analyze, you use a protocol analyzer or network monitoring tool, you see this. A protocol information is added at each layer of the OSI, right? So at layer 2, you would see like maybe for your data link layer, you would have like the LLC. So for 18, it says describe the data frame pertaining to OSI layer and how the data is transmitted. So a frame is basically a protocol data unit at layer 2. It contains a group of bits, and it allows those bits to be able to synchronize and prepare. So it frames it before it brings it to the next layer, which is prepare the data. When you see payload, that's basically data for the packet. Okay. Because ultimately, after we route the packet into the network, it's going to use that frame to determine which system receives that data. Okay. It's kind of like the router gets you to the exit. The frame is going to get you, the switch is going to read that frame and get you to the house or the street, right? The segment, and then the house that you live. So it prepares it for the packet payload, and it checks the sequence to make sure that your data is intact. Remember what I said about the bicycle parts, right? This is when it's going to really determine like, oh, that's a handlebar, that's a pedal, right? So this is the sequence check. So this is going to be used for encapsulation before the data transmitted and also when it receives. So once it's transmitted and come back, right? So each frame is then divided and it's going to have a gap so that way it would know individual frame for your data. At layer 3, you're going to have packets. This is for routing only. This is for switching. This is for routing. So at layer 3, the packets is then used to transport your data from one network to another. Framing is used to transport your data, right, from one system to the next inside, right, the network. But when it leaves the network, it needs to become a packet. So it has to frame and then becomes a packet. And that packet would have headers where it would know like which network that comes from, how did it get routed there, right? So it's a way to transport. So think of it like it would contain trains, planes, right? And all the trucks that get your package from California to New York. So the internetwork. And so that means that your packets each can carry multiple one or more Ethernet frames. So when we're analyzing traffic that's coming in and out of the network, we're looking at them as packets. But when we're analyzing the data flow within the network from one system to another, we really need to take a look at our lower level, which is that frame. Any question? I'm trying to reserve some time today for the cabling. Like some of you are gonna be like quick and it's gonna take you like 10-15 minutes and you're done, right? Some of you might take a little bit more time, so you know you should take the time that you need. But I want to make sure that I give adequate amount of time for everyone. And because you know, also the tools, we don't have like a lot of tools, we have good amount. I bought some out of my own pocket so that we guys can have the newer tools. So I'll talk about that next, right after the assignment, before we take a break and take attendance, or take attendance when we come back from break. So let's finish this up so we can talk about that. Oh, I lie. I said 20, but it's 22, which is shorter than most. Next week it's gonna be a lot longer. But I'm gonna try to like give you time so that way you can do your lab. We're gonna do a little bit of NIC configuration next week. So I'll get you slowly warm up to like using virtual machine and configuring your system. And so leaving this class, remember after each session, try to add something to your resume list so that way you remember, like after today, need to put down cabling, coaxial, and Ethernet if you're successful. Okay. If you're not, I will try to give you some time next week, but try to do that every week. All right, Ethernet. We talked about this last time, maybe before the holiday, and you might not remember. Anytime you see IEEE standard 802.3, that is Ethernet. If there's no letter attached to it, right? So if you're using Ethernet cable that falls under the Ethernet, there's limitation with Ethernet and how the data is sent. And the communication and the media. So it's tied to like cabling, it ties to the systems that's handling that and all of that. So Ethernet is defined as 802.3. And then when you're dealing with wireless, and we're going to have a whole chapter on wireless, right? Wireless communication is 802.11. So you probably heard about this, but they're a different class, right? Long ago, everybody wanted to get wireless. So you have class A, class B. So 802.11a, right, have different speed. Faster, right, but there's some issues with range. So to transfer at 11 megabit per second, which to most of us now is very slow, right? You'd be like, oh, that's too slow for me. I can't game with that, right? So 802.11b handles at 11 megabit per second. There was some incompatibility issues going from A to B, meaning that if you're using B, you have in your wireless network. So if I buy a router that is 802.11b, I have to upgrade my network adapter to 802.11b, right? Now you have the AC. Most of us just have AC devices because that's what we use now. But there was, when they built this, there was a gap. So after B, they integrated what's called G. Okay. And so G gives you better throughput, 54 megabit per second, which is fast, right? And it is backward compatible to B. So if I have a bunch of laptops that has that wireless adapter at B, I can buy a G router and it should work, right? That didn't happen before with Team AB. And then after G, they integrated N, and after N came AC, which is what you have today. And they are getting ready to release the next one. So IEEE is an association made of scientific people, researcher, professional, the industry, vendors, right? They got together and they really talked and discussed the type of technology and the standard for the technology that's used. And they also host like conference and events. So and the world use what we see with the standards. Okay. So this is kind of giving you a little bit of details. And I want to mention that most of your devices, right, operates at 2.4 gigahertz frequency. For example, your smart TV. Some of you have really fancy smart TV that's capable of connecting at 5G, right? You ever tried connecting your smart TV to your wireless network? So the rule is, if you have lower frequency, you can span longer distance. So with access point, when you're scanning for access point, most of the time you would see that they would install 2.4 gigahertz access point. Now, if you're using AC, that's dual band, right? It uses 2.4 gigahertz and 5G, so you have an option. But if you're using 5G, it is higher frequency. It's not able to go the long distance. So in order to get the long distance, what do? How can I get my 5G extended? Get an extender, right? But if you're familiar with extender, most extender are kind of like kidney failure. Yeah, they're kind of boo-boo. Okay, to be honest. So, if you try to extend like your wireless network at home, you can try it and let me know which extender works for you. Some router comes with the extender, right? So a good wireless network is a network where you don't have dead spot, right? You know how when you walk around campus, some part you kind of get the low bar and some part you get the high bar. Same thing with the mobile network, right? So are we working with effective network? But sometimes we would have efficient network, but not effective network, right? So you have to kind of balance like performance and efficiency, two different things. Sometimes cannot be mixed. Right. So any question? Okay, so before we take a break, let's talk about cabling. I know some of you have done this. Maybe if you have, you want another spot.
25 gig.
I haven't taught 25 for a long while.
Oh, that's what I remember doing.
Yeah. Okay, so we're gonna make some cables today, right? I did buy you push through connector to save you the pain because I have experience. Now, some of you would start with an Ethernet cable first, so I'm going to ask you today to be patient with yourself. The first time, if you make this the first time, likely that if you mess up, just cut it off and do it again. It's okay, right? I did it too. So what you're going to do is you are going to cut from this box, right? You're going to use a wire cutter. Put away all of these tools to be sure. One of these are the larger ones. Maybe it's on the bottom. You're just gonna pull the cable. Start with like an arm length. Okay. Do not cut this big because if you mess up, it's gonna be this big and you can't put it in the tester. Okay. What you're gonna do is you are going to strip off the plastic coat on the outside. Okay, there are two ways of doing it. You can take, this is a stripper, rotational one. When you look at the alligator mouth, there's the dial with the number. This one says 56.6. That means that this is for the RG6. You can change the dial by, be careful, this has razor, okay? They're sharp. So when you pull this off, you can take this part out by pulling this and flip it upside down. Okay. Now sometime the razor come off, call me over and I'll help you. Okay. So some are very sharp. So when you rotate a full rotation like the video show, what will happen is you're going to cut off your wire. Okay. So in that case, if you strip, just do a light strip so we can put it through. So there's two, right? this alligator mouth in the front right here is for specific sets. We can change it, the 7 and 11, that's for cat 7 and cat 11. Cat 11 is for the telephone. Okay, like the telephone line, some of you probably don't know what that is, right? You go to your grandparents' house, and if they have a phone that's connected to a line, that's a telephone line. Okay, now, if you're using the coaxial, you can strip it here. You can also feed it through the middle hole here. When you open up the alligator mouth, there's a razor there. Don't stick your finger in it, right? So when you strip, put it through about at least an inch. Okay, give yourself some room. Hold with one hand and rotate, right? And then take the stripper off, and you're gonna pull off the plastic coat. Like so, right? I strip. You're gonna see this little fibrous hair. This is for insulation. You can cut it off, right? Ultimately, it's used for cooling the cable because it gets hot. Then we're gonna untwist. There are 4 pairs and there are 8 wires. You have to untwist it and make it as straight as possible. Okay? And you're gonna arrange it to the color for the standard that's provided on the lab, or you can go look online, right? Some of the stripper and the crimper combined, they have a color code on there. If you're making a crossover, one end is gonna be standard A, and another end is gonna be standard B. Okay? If you're making your regular Ethernet cable, they both need to be standard B. Okay? So that means that I'm going to take the white orange, the striped orange, and if you're colorblind, you can ask someone next to you to help, or I can come and help do that. Some people have that, right? It's okay, right? So the white orange and the solid orange are twisted together. You untwist it, and the white orange has to be the first pin. So it's going to be the first one on the left. Okay? Any question? All right, we're gonna arrange it to the color. So if you're making your regular Ethernet cable, they're both exactly the same. Whereas the crossover, when we use a switch to a switch, or a router to a router, etc., they are gonna be crossed in different signals. Then you're gonna take 2 connectors. Okay. This is an RJ45, and if you ever use a phone line, it looks like an RJ11, but bigger. This is where your Ethernet cable, you guys plug Ethernet cable in, you know, right? The tail is always, the clip is always on the bottom, okay? And when you insert it, it's always going to be away from you or on the bottom. And pin 1 is going to be on your left. So after you arrange all your wire, right, as straight as possible, you're going to take your thumb and hold it down, right? And you're gonna insert it. This is a push through. So you're gonna push the wire, and each of them are gonna have its own slot. Okay? You're gonna find that that part is kind of hard because sometimes they kind of got mingled in together, right? Do your best. The straighter it is, the better. You're gonna push it through, and it's gonna peek through. At the end of each connector, you're gonna see that there's the metal piece. That's called the conductive part, the conductor. You have to get it past the conductor by a little bit so you can just trim. Okay? So, and the connector, it needs to sit like, the end of it, the crimp line needs to be about 2 centimeters above your plastic coat. Because if you have your connector like so, like this, and you crimp, I'm gonna pull it right off because it's just gonna fall off. The crimp line is designed to hold it in place above the plastic. Okay. So once you insert, you're gonna take this thing, right? This is an old crimper. Again, it has a cutter and a stripper with it. Be careful with the razor. And then I bought you some new ones that look like this. Okay. If it's held down like this, there's a lock button. You just push it and it's going to open up. Now these, you are going to insert them to the 8P, which is the larger connector here. They trim and crimp. Okay, so all you have to do is insert the connector with the wire in and press down on the handles. Squeeze it, right? And it's gonna trim off the excess wire and crimp down your connector. Yeah. And these, right, they don't trim. So you're gonna insert the wire with the connector and trying to be careful because sometimes they fall off. Like so, right? And it's really simple. The tail goes where it's supposed to be, so you insert it like this and then squeeze it, right? So when that happens, the connector, there's a crimp line, it's gonna press down on your plastic coating of your cable. Once you crimp, and if you mess up, you gotta cut and start all over again, okay? So before you crimp, check your color code, check to see if it reaches the conductor. You turn it around, you see all the little wire, right? And it's a push through, so in excess, you can just trim it up as straight as possible, okay? So do both ends. Once you have that, you're gonna take a tester, you're gonna turn it on. And you're gonna take one end of your cable, gonna plug it in here, the other end plug it in here. If you do an Ethernet cable, they all should line up from 1 to 8 in parallel. Okay? I want you to take a picture of that. I don't need 8 picture, but 1 picture, like on line 8, right? That your cable passed. If you do a crossover, it's gonna cross signal like 1 to 3, 2, 2, 6. So it's gonna cross based on the wire arrangement, and you can do that. So you have an option to do a straight through, which is your simple Ethernet cable, standard B on both ends, or you can do a crossover A and B. Okay, one Ethernet. Then you're gonna do a coaxial. I want everybody leaving the class on have to do cabling, because that could be your job. Okay. So coaxial, I'm sure some of you've seen the cable TV cable, right? This is a thick net, and the box, I will put that up here with the tarp. So you pull the cable from the inside, use a wire cutter, cut it. Just start with an arm length, that's fine. You're gonna take the RG6 or the F connector, right? You're gonna need 2 of them. So I'm gonna take one out, and these are compression F connector. When you look at the connector, the hexagon end is going to be the mouth of it. That's gonna be where your needle is gonna be. Okay, so when you insert it, the hexagon end is going to be where it's gonna be the front. Got that? Okay, because the other end is just round. Okay. Then you are gonna strip it just like how you strip the other one, but there are 2 parts. Okay. So instead of putting it through the middle part of my stripper, I'm gonna use the 56, the 59.6 here, and I'm gonna strip again. Give yourself like about an inch, and you're gonna strip. Just rotate. Now, some of these are kind of dull, so they don't cut 2 parts, so you can do it manually. First, take off the cord. Remove the coat. You're gonna find that this is a twist, an STP, a shielded twisted pair. So an STP cable has these foil. You can see that there's like little foil pieces in here, like this, right? This is carbon. And you're gonna see this fibrous hair. Do not brush them all off. So you're gonna fold them back like how you do a banana. Okay? You wanna keep banana. You're gonna keep the hairy pieces. They might fall off a little bit. It's okay. Just keep doing it, right? And then what you want to do is you want to first also take off. So the first part is going to be your needle part, okay? The second piece, because there's 2 pieces to it, when you strip, some did not cut the second part. I'm going to do a live rotation. So I want like about 2-3 centimeter. So I don't want to take everything off, because if I do a full rotation, it takes everything off. Then what I want is I just want to take the plastic coat off. And you want to leave, so you can look at the last picture. and a video. So once you take the plastic cover off, sorry. Be good. Okay. Now, if you strip it with a sharp enough stripper, it's gonna take the core off and the second piece. So you're gonna see the cut with that. So it's gonna look like this, okay? The needle part and then some core. You're gonna fold it back, like I said, like a banana. Okay? Then you're gonna take the connector. Remember, the hexagon part is facing away from you. That's where you're gonna connect the cable. You're gonna take the regular round end and you're gonna push it down as much as possible so you can. Okay. Because what will happen is after you compress and if you don't push it down far enough, it's gonna fall right off. You don't want it to fall right off. So once you feel it kind of tight when you push it down, you're gonna take a compression tool. There's two kinds. There's this kind, and then there's the red handle kind. Same thing, right? What you're gonna do, if this part is too long, what will happen is it's gonna get stuck in here. So we have a hole. We're gonna open it up. We have a hole here. We're gonna insert the needle part into the hole, and we're gonna seat it, right? So I might have to trim this guy. We're gonna seat it down, and we're gonna press it down. And when that happens, it's gonna compress. Sorry, let me clean up my cable because I made the other things. So it's too long. Now you want this needle part to be like right flush at the mouth. If you work for Spectrum, you will not pass if it's like too much, too high or too short, right? They will make sure that you pass that. So if it's like this, like maybe a millimeter or two above your mouth, your connector. So see that like this. See how I just laid it in like that, like put it in the hole and then lay it down horizontally. And then with both hands, just squeeze that. It doesn't take a lot of force. And then what will happen is, right? You are gonna see that when you compress, look at my compressed cable, right? So you can trim it off a little bit. This boot, this black boot is shorter than the non-compressed one. So when you look, right, when you compare, it's like 2/3 shorter, okay? And you should not be able to yank it off. And that's how you do a coaxial. I don't have a tester for coaxial, right? Once you guys just bring it up, right? So this one, see how it's still kind of long? Just take your wire cutter and trim off. Just cut it as straight as possible. Like this. Right. And be careful with the bits and pieces. Just clean up your area when you're done. And then now I have a coaxial cable, right? So I want you to do one. I would start with this one first because most of you will be like 90% successful with it, right? Or it's very quick. And then do the Ethernet one. But if you want to tackle the harder one first, do the Ethernet one. And then do this one. So this one should take like a few minutes. Where this one would take like 15 to 20 minutes if you still practice, right? Okay, all right. Let's stop recording. I didn't record for the Friday class, but I kind of showed them.